Hey guys, welcome back to another episode on Linux kernel UDP header data structure, which is struct UDP header. And in my previous video I have discussed about the introduction of this data structure, and also I have done a code walk of struct UDP header data structure header files, and also I have shown you various instances at which it's been used in existing Linux kernel source as such. So in this episode I am going to show you a live demonstration of sample code which is written by me, and in this sample code it parses each incoming IPv4 UDP packet, and it is going to show its source port and destination port and things like that. So this gives a live demo of parsing the UDP packets and displaying in the kernel varlog messages as such. So in my previous video, although the UDP stack is used, it is used in the existing kernel source as such. So, and this demo is going to help you in terms of really visualizing these packets in the way and in the order they arrive into the system as such. So let me just take you to my desktop, guys, and let me show my code. And as usual, I don't write kernel modules as such. So my code is very much a part of Linux kernel source, and then for that I usually compile the kernel and then boot with this new kernel, and then I'm going to show the demo as such. So let me just take you to my desktop, guys. So guys, this is my Linux kernel source sample code, guys, which I have added in net IPv4 IP_input.c, and this is a sample code which I have added throughout my video series as such. So initially I have added this in terms of understanding SKB data structure in my SKB data structure video series, and you can see those videos in my channel as such. So somewhere around part 13 or somewhere I just included the first sample code in terms of accessing your SKB data structure and parsing the data structure, and you can just parse each incoming packet. Since this flow is in IP_input.c, this is this is where this actually intercepts incoming packets which are destined for local system as such. So it displays some of the SKB details, like its incoming port name and things like that as such. Later in my other video, like IP header data structure as a sample code, I have added this additional code where it actually parses each incoming IP header packets IPv4 header, and it prints its protocol and it branches out with this switch case statement, and then it also prints this source IP and destination IP and things like that. So now I have extended further in terms of understanding the UDP header data structure, and I just inserted this new code in this location as well. So what it effectively does is, in case if this is an IPv4 packet, and in case if it is IP proto UDP type, it prints this IP protocol is UDP, and then it extracts the UDP header pointer from the SKB data. SKB data is this, from SKB data location. So the SKB data may effectively start from IP header, or it may start from Ethernet header access. So it exactly, this API allows you to get the exact location of the bytes from where the UDP header starts access. So you get effectively this pointer, and it is stored in this pointer access. So from here we can just print the UDP header source port and UDP header destination port and things like that. So you just need to convert it with this API network to host short, so that it makes it compliant with the system as such. So you can use this network to host short API for these two variables, and you can just print this. This is a 16-bit data type, and you can just assume it as unsigned short data type, and you can just print with this format specifier as such. So HU is you can use as such. So I'm just printing this with %HU, and then As you can understand, one of the most frequently occurring UDP packets in a system is DNS packet, and in that case I'm just adding this extra line in case if you find any packet, its source port or its destination port is equal to port number 53, and in that case you can just print as it's a DNS packet. So that's what this statement, additional statement, does. So this I hope you can understand. It gives a good example of struct UDP header. I just don't want to print all other fields such as your UDP header field which is length and UDP header field which is checksum message. So I just want to ignore. As you can understand, these two are the important fields in the UDP header data structure actually. So I'm just printing the source port and destination port of this corresponding UDP packet as well. So I just told in various videos I am not a big fan of inserting a kernel module and then compiling the kernel module and inserting the kernel module at the runtime as well. So I just love adding a code like this in the existing Linux kernel source in whichever API or whichever flow which I want. So I just added this entire chunk of code in this API, as you can see, and this gives the freedom effectively using this way. In case if you do a module, it is easy in terms of inserting the module at runtime, but it is difficult. You need to write all other kernel module code, and you need to do the registration, and then you need to hook the net filter packet this thing, and then you need to add your code so that it gets the right hook of the context of your packet. So this eliminates all those things, and as you can understand, the code is very simple and straightforward, which is easy to understand. And this is hooked in net IPv4 IP_input.cs. So what I have done is I have just compiled this entire kernel, and since it is a part of kernel, as you can see, I just compiled the entire kernel and I have installed this kernel, and currently I booted in this kernel as well. So directly we can open kernel's verilog messages, and we can see these print case in action as well. So let me just open the terminal, tail -f verilog messages, and inside in the Ubuntu Linux it is actually verilog kern.log file, whereas in case if you use Fedora or something like that, it may be in the file called verilog messages. So let's just print this file. You can see it is getting these UDP packets in the local loopback. I just added some some sort of test service as well. So I think these packets are arriving from that service as well. So apart from that, now you can see some somewhere else it is also, I think this is it is sending these UDP packets to my Wi-Fi. Let me just cancel this. Let me just stop this capture and go back. Yeah, I think these packets it is just sending and receiving from the Wi-Fi router as such. So that is this packet, and again, since it is UDP packet, it is showing this additional line saying that it is a DNS packet. So as you can understand, this can be a port number 53 at source port or port number 53 at destination port. So I just written the code that either case, if it is source port is 53 or destination port is 53, just print it's a DNS packet. So that's what it is happening as such, as you can understand. And in case we can just do the debug messages once again, and let me just open any test website. Yeah, let me just open a test website, and in this case let me just stop this capture, and in this case you can see it is also sending these TCP packets. Since we don't have any further parsing happening in the TCP packet TCP packet flow, it is just printing this IP protocol. So there is nothing else after this branching out. There is nothing else is there. So unlike this UDP protocol, so it's just printing it is TCP, and then it is printing the source IP and destination IP. And as you can understand, if it is a UDP packet, it is printing all these things. So there you go, guys. I hope this gives enough picture in terms of how you use your kernel's struct UDP data structure, and in my subsequent videos I am going to show you some more examples in the existing Linux kernel source, and some more maybe some more APIs which relates to this data structure. So that's all guys for this episode. I hope you liked watching this video. Please do subscribe to this channel. Please give thumbs up to this video in case if you liked it. Please do share it with your friends and colleagues. Thank you once again for watching this video. Thank you. Have a nice day.